Hey, what's going on, guys? WukongJS here. I keep working on the JavaScript port of my chess engine Wukong that was originally written in C programming language, and the current issue I'm facing now is a very slow mode generator. So, despite the fact that JavaScript is about 5 times slower than C, still there are lots of improvements within the mode generator to make in order to actually in order to make it faster. So due to the fact that I had no idea where the delays are coming from, I decided to create my custom little profiler, answering the simple question on how much time taken by the critical functions within the mode generator. So by saying critical functions, I mean those that take in the most time in the overall process. So if it comes to C programming language, there are really cool profilers that telling you literally all the time taken for every single little tiny function being involved within your code that is running. But here in JavaScript, I know that there are just a few functions that taking the most time, and the rest of the functions taking the miserable amount of time. So we cannot even count on how many times did they take. So I can just run this new profile version either in the console or via Node.js. So Node.js would be a little bit faster, I believe. So 9.8. Yeah, so Node.js is a little bit faster, but it just was an unfortunate try. So it may go a little bit faster in the browser as well. But anyway, the idea is that I'm calculating the time taken by this most heavy functions within my mode generator. So square attack is used to answer the simple question that whether the king has been exposed into a check or not. Generate moves is responsible literally for generating moves, and these two functions are especially interesting. So board copy is the part of a make move, and you can see that it takes kind of the most time of the entire make move function. And yeah, so we have this time taken for make move function, and add this to this square attack plus generate moves, we'll have around of this number. And again, like so if we just so here, in some of the different tests, let's compare the numbers. So if I just say like, if I just say 305 plus 196, so 500s roughly, and yeah, make move. So here in the browser, make move takes even more than a square attack plus generate moves. Well, when I was calculating the same for within Node.js, it would be it was about equal. So let's say 305 plus like this. So still okay, like 400s, and make move also takes almost 400s. So yeah. So it seems like the make move works slower in the browser compared to the Node.js, but it doesn't matter really that much at the moment. So the problem is that, unfortunately, my square attack function started working about 200 milliseconds slower due to the fact of being refactored. But a few words regarding refactoring and the updates on the code would follow later on. Now I just want to mention that the vast majority of the process, of the processing power is actually taken by the make move function, which is clearly seen here and especially here, and the vast majority of the time taken to complete within the make move function itself is this board copy. So just to give you an idea how on earth am I doing this? So I'm having the global time accumulators. And I'm having this start label where I'm just I can see the time. So I'm just starting, like literally starting the timer, and here I just calculate how many milliseconds was taken to the single execution of a given function. and then all this thousands or even millions of single executions are accumulated into a single variable. And exactly the same technique is used for all the critical functions I'm interested in, like this in square attack, generate moves, make move board copy, and all this stuff. So this sort of a profiling actually made me reveal the fact that the board copy takes the most time, and now it's getting really clear like why people actually trying to incrementally update the board position when it comes to the take back function. So instead of copying the entire array, it's much faster to move the piece back and restore the captured piece if needed. So that's kind of the core idea. And I didn't do this yet because I wanted to keep my source code as soon as possible, but for those of you who has been following this series, you've probably seen that you can probably see that I've dropped the commentaries and tightened the code, and now it really looks like it shares the style of this one of Harmgerd Miller's code, which is the chess programming legend. Basically created the smallest chess program in existence, Micromax. It's not the source code of that program, is the source code of his chess variant written in JavaScript, but the style of the source code is quite pretty, something that I also like to use in my own project, because I kind of stopped fooling myself by the fact that it might happen that somebody would be reading my code. At very least, I have at least 5 chess engines where every single line of code is being commanded. So if somebody's about to learn how chess engine actually works, you can just see my GitHub and reference that as well. And a few words regarding refactoring that actually unfortunately gave me about 200 extra 200 milliseconds to my square attack function within this depth research. So this is how it currently looks like, this square attack. And just to give you an idea how it did look like before, so you see, like, we had duplicating pieces of codes, like knight attacks, literally the same piece of code as the king attacks. The only difference is the piece to check whether there is a king, white or black on the target square, and what kind of array of offsets to iterate over here. So there we had king offsets, here we have the knight offsets. And exactly the same story for bishop and queens and rook and queens for leaper pieces. So this piece of code is literally the same as this one. So in order to reduce the size of this sort of a stuff, I've created this map and variables. So I can deal either with the pawn directions, like for white pawns and for black pawns, respectively here as well, and also for knight and king and for bishop and rook. So I'm just specifying the pointers to the specific offsets that I need there, and also when you need to check whether the proper piece is available on the target square, I can do this as well by I have the side and move variable having the value either 0 for whites or 1 for blacks. So that's how I can easily index my leaper piece offsets, leaper piece side, and slider piece sides. Here I'm comparing with not only bishops, but bishops and queens, and blacks the same, rook and queen here the same. So eventually we have this only 3 pieces of code, no more duplications, and this is how it looks like. So I'm just using this leaper pieces offsets indexed by the index, the specific offset, and if we need to figure out if there is a piece, we just index and decide by the color, and that's how we done. So this is it basically. So I don't know how do you like this refactoring, but me personally, I really love it basically, even despite the fact that it's now working a bit slower. And I'm gonna be making absolutely the same stuff regarding the generate moves function. So I hope that will be making sense as well, because you see, like, all these pieces of code, they all are duplicated here, and the same for this piece. So that was the castling and point mode generation. Here we have king offsets, knight offsets, so literally two absolutely the same pieces of code. So I just want to reduce the resize in exactly the same manner I did this with a square attack function. So hopefully my generate move function would be much more compact and without this weird duplications, even though it would cost me some extra time, but still, because all this nested pointers nested pointer references actually seems to be taking some time. But anyway, this is how the source code looks like now, and this because yeah, like from now on I'm actually no longer again like fooling myself that I'm making this for someone else but me. So, and as far as I'm making the from now on I'm writing this chess engine really only for my own self, I think that this format is more appropriate. So let me know in the commentaries, guys. Please let me know whether you like this new appearance of my source code and what am I doing here or not. So, or maybe you love the commanded version more. Anyway, you can reference the commanded version in the previous commits here on GitHub. So just to give you an idea, well, it is regarding the move generator. Well, obviously that would be the weird and slow move generator right over in there. But anyway, well, where is this? Here it is. But at least you will have a basic understanding of how the things work. So I think that could have made sense. So here we just go to the commits part, and here, like before this, refactor the square attack and remove commentaries. So this one, improving mode generator. So here you can see the source code of the previous versions. And as always, well, I didn't yet commit and upload the track development progress page, which is changing all the time. So by the time when you would be watching this video, this sort of a page that is available in public probably wouldn't be available. But still, if you're interested in the development progress regarding this sort of a project, you can always track it right over in here. But again, like I didn't yet update the current commit that you see that you've seen here in my code editor. Well, okay, guys. So I think this is it. Or hold on a sec. No, I actually did. Yeah. Hold on a sec. Why did I say that I didn't? Why I actually did, right? Yeah, I did because. Hold on a sec. I did because yeah. Because the commit is already there. Yeah. Sorry, guys. So this is already kind of like no commentaries version. But again, like by the time when you would be watching this video, most likely this would be completely different. So this is basically all I wanted to share with you guys today. And again, like I'm really interested regarding the feedbacks of what you've seen here in this video, and what do you think regarding what am I doing with this chess engine. So please let me know. This is it from my side. Until the next time, and take care.